Welcome grade 8 to our review video on this unit that we've been stepping through. This unit on congruency, similarity, as we step through certain things within geometry. And as we get to the end of this unit, this is going to be a bit of a recap video, and there's also included the In a Nutshell page that you should check out, as it gives a little bit of a summary of congruency, similarity, and scale factor. Just as a reminder that although this is going to cover a bit of a review, it is going to cover it at a little bit of a broader level. So if you want some more specifics, feel free to go back to any of the previous videos and take a look at some of the specifics involved with congruency, similarity, and scale factor. As we go through, keep in mind that we're doing things a little bit different. So we are going to be doing the review questions after that, and that's going to be the conclusion of this unit. So there is not going to be any formal unit test at the end of this particular math unit, but your review questions will act as a way to put down what you know, as a way to review and to make sure that what you have learned over the last number of weeks is sticking into your mind. And then we'll be starting our next unit shortly thereafter. So first of all, we started talking about congruency and whether something was congruent. And if you remember that for an object to be congruent, there needed to be two things that were true. One is that they have to have all corresponding sides equal. And two, all corresponding angles equal. So essentially what this means is they're the same shape, exactly the same shape. It's not a bigger or a smaller version of it, it is the exact same shape. And there are some different things that we can do with congruent shapes, but they are the same shape. Now there are three main things that we talked about that we can do to congruent shapes, things that we call transformations that still keep them being congruent. The very first one was a translation. And a translation of a shape is simply a shifting or a moving of that shape to a new location. And so you have a triangle here. Let's say you were to shift it in this direction. Well, now your new triangle is right here. It's still the same shape, still the same triangle. It's just shifted a little bit in the X direction and a little bit in the Y direction. We talked about how with translations, if it's a positive X value, it's moving to the right. If it's a negative, it's moving to the left. If it's a positive Y, it's moving up. If it's a negative Y, it's moving down. But otherwise, it's just a straight move, and all the points move the exact same amount, and they continue to follow and create the exact same triangle, just in a new spot. Second was a reflection. And so a translation is kind of like a slide or a move, whereas a reflection is kind of like a flip. So we talked about reflecting on a certain line. So in this case, if I have that same triangle, and let's say I'm reflecting in the y-axis. Remember that the one going up and down is the y-axis. Well, then I'd have a shape that's just kind of right over here. It's the flipped version of it. But the shape is still the same size. The angles still line up. It's just a flipped version of what the original one was. And so this would be a different type of transformation. We talked about reflecting it in the y-axis, x-axis. We've even talked about having other lines like x equals 1, x equals -3. We could create different lines that they're flipping from. The important thing is that however far that shape is from the line, make sure it's the same distance or equidistance on the opposite side. And then the next part, after reflection, we have, and this is one that some of you may have struggled with a little bit more, a rotation. And a rotation, if a translation is a slide, reflection is a flip, rotation is like a spin. And we talked about how this spin, so let's say you had the object here, We could spin around a certain point. Sometimes it's the middle point here, what we call the origin. And you could create that shape then in a new spot. It's spun around that particular point. This one here, we talked about spins that were like a 90-degree spin, which is basically a 1/4 turn. We talked about 180 degree, which is a half turn. And we also talked about a 270 degree, which is a 3/4 turn. We talked also about how this spin could be clockwise, which means that it goes in the direction that a clock normally would, or it could be counterclockwise, which is the opposite direction. So it's going in that direction instead. And so these are all different things that we can do to a congruent shape that would still keep its congruency. Now, something else that we had similarity. And similarity, there are some things that are the same, but there are other things that are different. So with similarity, we can say that all corresponding angles are still equal. However, we can't say that all corresponding sides are equal. All corresponding sides, though, the ratio of the corresponding sides are equal. In other words, similar shapes are scaled up or scaled down versions of the original shape. We might have an original shape that's something that's rather small, and so we make an enlargement of it or make it bigger. All the angles stay exactly the same, but it's a much bigger version of what it was before. Or we could do the opposite. We could have, for example, maybe we have a mini replica of the Eiffel Tower. Chances are you don't have the actual Eiffel Tower, but it has all of the exact scales to it. Maybe you're a big car person, and you have something, and it says on it that it is an exact replica, but it is to 1/16 scale. That's exactly what we're dealing with similar shape. In other words, all the angles, all the design features, and everything else are exactly the same. It's just 1/16 the size. And so with similar shapes, we talked about that. We talked about how the image of an enlargement or reduction is similar to the original figure, and that those ratios are also kept the same. So, for example, if I had a box here, I could have a little box here. Maybe that has a 1/2 scale ratio or scale factor. In other words, this is 1/2 the size. Or this is called a reduction. Or we could scale it up and it has the same angles, but this is maybe 3 times the size or has 3 scale ratio or factor. And this is called an enlargement. In other words, if this is 5 centimeters, this would be 2.5, and this would be 15. 3 times as big, half as big from the original. And we also talked about how scale factor, we can use scale factor in order to compare side lengths, in order to solve some of the missing side lengths as well, to figure out how big something would be. So for example, if you know that you have a scale factor of 15, if you know that this side length is 5 centimeters on the original, by this one, which is 7 centimeters, and then on the actual thing that you have, this one is 20 centimeters. So what's this going to be? That's the unknown. We can use this idea in order to solve that. So this scales up, right? 4 times 4. Do the same thing here. 7 times 4, which is going to be 28 centimeters. I could also set that into a ratio, right? 5 centimeters over 20 centimeters equals 7 centimeters over x. And I could use all sorts of different ways in order to be able to solve for my missing variable. Again, if you're stuck on any of these particular types of questions, please go back and take a look at some of the specific videos and some of the specific examples to get an idea of some of the questions that may be on these review questions coming up.